represent a very broad variety of perspectives on this topic for security, and I'll let them all introduce themselves, starting at the end with Andrew.
Hello everyone, I'm Andrew Ginter with Waterfall Security Solutions. We're a technology provider. We do the unidirectional gateway family of products. My own background is developing control system product for HP and Agilent for many years, developing IT-OT integration, connecting a lot of networks together, contributing to the security problems that now plague the industry, and then got religion, wound up working for Industrial Defender and for Waterfall.
And I may add that Andrew just wrote this book a few months ago on SCADA security, so if this is part of your process, you may want to take a look at it. JP.
Yes, I'm Jean-Pierre LeBlanc, or JP. If you know what ISOSISU means, probably means that you spent some time up in Helsinki. It's two Finnish words, one which is ISO, which means big, and sisu, which means guts. So big guts or big kahunas or whatever you want to call it. But I thought I wanted to be an entrepreneur. I'm an independent consultant. I'm one of the co-authors of the security framework. I got 20 years of military experience, so security is kind of in my blood forever now. I've built secure platforms. I'm an expert in using virtualization and separation kernels. And I've taken this type of technology to build trustworthy systems.
My name is Marcellus Buchheit. I represent the company of WibuSystems. It's a 27 years old company, strictly focused on original software licensing and now also security of software, original in the IT world, moving from there to the OT or Internet of Things world in the industrial. So for me it's an interesting focus when you see what in IT was established in security, how different this is used in OT and the challenges you improve. And I'm also one of the co-writers and co-authors and editors or whatever from the IISF. And this proposed me a lot of new input in how to form safety and all of that, who I never know much before.
Hi everyone, good morning. My name is Nisarg Desai. I'm a product manager of IoT at GM of GlobalSign. We are a public CA and we've been providing PKI-based security solutions for a long time now. Over the last about 3 years or so, we've been transitioning, and I've been looking at how to take our PKI experience and expertise and apply it to solve a lot of the different problems in IoT, and we'll get to that in the panel. But we've been fairly successful in that, and I'm here to learn what the different problems are, how we can work together to solve them. My background is in virtualization and endpoint security for enterprises, and now slowly and hopefully moving towards the industrial side of things.
Thank you. My name is Molina. I'm here with Fujitsu Limited. I'm the co-lead of the security working group here at the IISC. I also help Fujitsu with the factory operations and facility intelligence. It's one of the tests we have. We collect information from 2 factories in Japan, and we evaluate what the information means, try to make analytics and a platform which everybody can use. I have helped the RSA conference to do the IoT sandbox, which made me famous for the Barbie opening and Barbie hacking thing. I also have worked a little bit in evaluation of hotels. And you share hotel hacking, Jesus Molina, you will find interesting thing there. I'm here because, again, I have been working with the IISC in developing the framework, and all these gentlemen trying to see what can we do to make the smart factories and dumb factories, which I will describe a little bit later, safe and secure.
Excellent. So thank you for that. Now, also, Dr. Molina did not mention that in addition to hacking a Barbie, for which my daughter will never forgive you, that he was also one of the guys that, while in China, hacked a hotel on several occasions. So if during your stay you notice the lights flickering a little bit, turn your attention right here.
Maybe not, but yes.
All right, so let's start off. So factories, smart factories, dumb factories. We've heard a lot today about factories and what is the potential, what can be happening. Security certainly is an issue. There's a lot of interest around the factories. One of the comments was, everything should be connected to everything. And this is an IoT statement. That's great. But are factories IoT or are they IIoT? Are they industrial IoT? What is different about industrial IoT and why should we care about security?
Well, I would like to take that first. I think there is 4 quadrants you have to see here. One is, just put it in one side, smart factories and dumb factories. Smart factories are factories that are highly connected, all have analytics. And dumb factories are factories that use PLCs, but still they use technology there. There is like smart security, which is having security which is targeted to your vertical and your industry, and there is dumb security, which is using antivirus in a factory plant, which is not targeted to OT but IT. Perhaps the most, in these 2 quadrants, you see like these 4 quadrants that I said there, the most damaging thing is to have dumb factories which have dumb security. Because if you have a smart factory with dumb security, still, that's very rare first, because if you have put your system to have a certain intelligent gateway to connect, already you will have some understanding of the analytics of the factory. But all these factories that run with all these PLCs and they keep saying, I don't want to be connected. That is the worst, because this is a very easy target for hackers to have dumb security in a dumb factory. And I will go a little bit more in details on how these attacks exactly happens and what kind of threats they have. But I will go through my own co-panel.
Andrew?
Let me give you a different view of that. To me, the difference between the IoT and the IIoT is one word: control. The vast majority of IoT products and discussion out there are about monitoring, not control. In our factories, of course, we have both monitoring and control. And as a rule, we care comparatively little about who is looking at our gauges from how far away through binoculars. The consequences of stealing monitoring data from our factories is similar to the consequences of stealing data on IT networks. There are consequences, but they're comparable. We can protect monitoring systems with IT technologies. Generally speaking, though, people in the factory care enormously more about who is standing in front of the dial, and they care even more that the dial is turned to the safe, correct setting. Control, the consequences of miscontrol are vastly worse than the consequences of stolen data. And so to me, the essential difference is, how do we enable all of the remote monitoring and all the remote data analytics that are vital to modern factories without introducing the risk of miscontrol of our critical physical processes.
So to add to what Andrew said, completely agree with the points you made there. On the difference in IT or IoT, I see this as a triangle with 3 different edges. The 3 different edges are IT, OT, and CT, which is consumer tech. And based on what your end product or end solution is, you fall somewhere within this triangle. And if you're a purely industrial provider, you would be more towards IT and OT space. But this triangle still remains in place. And what we want to do, for example, to the IISF, is to educate people on what are the different, A, the threats that face, depending on where you fall within this triangle, on which side, and then B, some of the different various measures that can be taken to address these threats. So I see this as a spectrum, and nobody is clearly on one side or the other. The risks and threats and solutions are all different, but you fall somewhere along this triangular plane, if I may.
Okay, so let's dig into that a little bit. So we've heard a couple of different perspectives here. So we've heard sort of the smart and the dumb perspective. Does that, and then, so if that leads to this potential topic of physical and cyber, which I haven't heard mentioned yet, how does that work its way into the control concept? Are there additional consequences on the physical side versus the cyber side?
There are. Look, there is a difference on how you used to do security in the past and how it will be done now in OT. When we think about security in IT, we thought about data. People's like confidentiality of the data. I don't want my data to be extracted. And that is like 70% of the budget of IT security goes. You know, there's like the SAT report which tells you what the budget goes in. Now, integrity of devices, it's something that people don't think about. They are starting to think about now a little bit because of this ransomware that happens. But integrity of devices on all these power plants, on all these factories, is not thought of. Started obviously changed the integrity of devices, and that was big news. But in general, companies don't think about it. And they don't think about it because there's no payload for them. There is no threat for them. They don't see any money getting out because there is not this payload that will control the whole power plant and do something really bad. The ransomware of your data being encrypted pales in comparison of the ransomware of somebody taking the whole power plant of every PLC and telling you, I'm going to blow this. You think this is not going to happen, but I was talking with a company called Clarity, which goes to the reverse, goes to understand every PLC in a factory to defend it. But imagine this same power that this company Clarity uses to understand every PLC and defend it to be used by an organization, say like, understand every PLC in a factory, create a payload that is a ransomware and take over that factory. This is not that far away, and I'm sure many national states are thinking about it. So OT, it's about integrity, IT is about confidentiality, and we have to understand the threats are coming and they're coming fast.
Okay, so if I can dig into that then deeper, into the entire panel then. Okay, so the consequences, I understand. Now, are the consequences the same between the Barbie and an IT infrastructure in an enterprise and an industrial deployment, say a factory, right? I would imagine that the consequences there would be very different. How do we have to change our approach? How do we have to change our thinking? Because I don't see a lot of industrial solutions. I see a lot of consumer side solutions. I see a lot of enterprise solutions. What about industrial? How does this concept of loss of control in an industrial environment compare to loss of control in these other environments that we're talking about?
Yeah, when you look to the characteristics of such products, when you look in IT, there is practically no safety issues. So the only thing about safety in a laptop is the power supply, or maybe the battery in a Samsung cell phone. Yeah? But in the industrial environment, safety is everything. That is the main goal, I would say, safety and reliability. You want that your system works well and it not is an endangering. And endangering means not just a robot arm can hit an employee, that's also dangerous, but it could also mean in production, you not produce dangerous products, especially in the, for example, in the production of food. You could easily make a mistake and bring some poisoning in, or in the car you could forget a part and this car the brakes are not working well. And this is things where the security suddenly interacts with the safety issues. And this is something we don't have in the Barbie, and we don't have even in a very secure, very high level IT infrastructure. And this is a big challenge, has to be addressed.
So I'll argue that we do have this in the Barbie, it's just nobody cares, right? So the consequences are very much less. So you mentioned this dependency or this interaction between safety and security.
I'd like to take that.
What else is it related to?
Yeah, so I'd like to say the magic word. Sorry for a person from General Mills. You know, it's not only in food that we need trust. It's not only in God we need trust, but it's also in our systems. And we talk about trustworthiness, but you know the key there is in these systems we need to trust. The trustworthiness is very key And we talk about that being the relationship between the security, the safety, the reliability, the availability, and the privacy of these systems. And so it's really important that that trust permeate throughout the system. So if you want to trust your system, you got to trust every component, where it was manufactured, all the way. You got to be really conscientious of that. And as the person from General Mills was saying, not only within your system, but within your whole ecosystem. So that partner that you're connecting to, do you trust that partner? Do you trust that system that he's connecting into you or you're connecting into him? And so trustworthiness is definitely the key differentiator between these two.
So I want to add to that point that you said about trustworthiness, and I want to call out another piece from the IISF that we have. When you want to say that you want to trust a person or a device that you're interacting with, or a different company's device that you're interacting with, we ran through this discussion yesterday as part of another working group session on if we have a lot of different companies that want to achieve one common purpose, and each can do one piece of the puzzle, how can we have a secure infrastructure, a secure method to enable this? And that's one of the things that we are trying to resolve. I believe the first building block of this should be identity. Can you trust someone or can you not trust someone? You first need to know who or what that device, person, or thing is. And the identity question is the first one that any person who wants to implement a smart factory solution or a plan should implement. You should be able to know all the different devices that are running your system. You should be able to prove that those devices are actually what they claim to be. And you should be able to manage these devices and authenticate and authorize or deauthorize devices within your system. You should have complete control of your system first, going back to your point on robot control. And all of this has to birth from identity.
So that's interesting. So if we need to have trustworthiness across our entire ecosystem, it's a bigger picture, that sounds like a pretty tall order, because within my own organization, I can't even build and have confidence in the integrity of my own devices and of my own processes. So let's say that I have, I have my boot attestation integrity, I have my runtime integrity, I have my process integrity. What about my supply chain integrity? I mean, oh my God, how do I even approach a problem within my environment to even begin to talk about the ecosystem?
Well, first, try not to freak out. Everything will be okay. I think that the factories are a little bit of a different beast. We're moving to a place where we're not going to deal with devices that can do everything. We are used to machines that interact with people, and these machines need to have a screen, need to have a keyboard, need to have a lot of processes there that are very, very difficult to evaluate. The problem you're discussing, where all these components from this computer come from. It is complicated. When you go to a factory, what I think, in my opinion, it will be is to create a trust on devices that perform a task, which is very simple, and connect in a way which is very, very understood by the monitoring system. So it knows what it has to do. There's going to be a lot of traffic in a factory about different web page traffic. There's going to be traffic about factory traffic. All devices will have some kind of identity, so identify the traffic, know what they are doing, where they are connecting. All this is possible if you think about factories on devices that are connected and are doing a specific task. Not like a million tasks, but a specific task. You have to do that. Identity obviously is extremely important. Supply chain is possible by understanding what all devices are doing, and you can provide a manifest of that to other factories. Say, I have all these devices there, and that's what they do, and this is my manifest. You can use blockchain. You can use other technologies to do that. So there is a way to deal with the supply chain, because it's a factory, because it's something that is not connected to a lot of people. It's connected between machines.
Okay, but so well, go ahead. Did you have a comment?
I was going to say I've got a different view of this. The security framework has a lot of good stuff in it. I'd encourage everyone to have a read. It's in fact of the security documents I've been part of, it is surprisingly readable. But if I may, one of the criticisms of the framework is that it is very general. It talks about the entire spectrum of industrial equipment, from monitor to control. And my own, specialty, my own main concern is control. And so I think that we do have a security framework coming, a safety framework coming. We do have other outputs coming that I'm hoping are going to capture some of this. But some of the concepts that contribute to the solution here, that contribute to a trustworthy design, are concepts like when we're controlling a dangerous physical process, when we can, should use hardware protections, not software. If the CPU is physically incapable of issuing unsafe instructions, well, that's a safer design than one where the CPU is physically capable of issuing those instructions. Or if the CPU has to be able to issue those instructions, then we should monitor it through one-way hardware that is physically unable to send any control or any signal back. If we have to send a signal back, we should send it over a communications channel that can only send abstract signals and is physically unable to send malware or to compromise the inside CPU. We should use two CPUs, one on the inside, running the critical process, one on the outside, that is expendable, that if it's compromised, all we lose is monitoring access. All of these design principles, many of them are touched on in the security framework, others I think still need to come. There is a way to do this, but we need to wrap our heads around this in a way that I haven't seen captured yet.
But how does that happen? So I have a factory environment. It's getting smarter, and I want to have optimization. I want to have better processing. I want to have more visibility. I want predictive maintenance. I want everything that everybody's promising me. But they're using these new concepts, the cloud, right? And you mentioned control. I don't see how the cloud and control works together. What am I going to do in my factory to realize that potential without completely compromising my security?
I mean, you build components together, and you have to trust this component delivers, and this includes the cloud service, the cloud infrastructure, and it's because we have one-day validation processes. In the moment, you just have to evaluate by yourself, and you have to trust specific companies or get some consultants and they check it. And then you have your system integrator, they build everything together, and you trust them that they're not just addressing reliability, that your production line works great. It addresses also that when you have this new addresses, cloud and remote access and whatever, that this is not compromising the security. And when the security is compromising also the rest of the system, like reliability or safety. And it's an evaluation process on a step. It is not a top-down process. It's more a bottom-up. That you see, I start with secure devices. I not use my old stuff where I don't know how safe they are. I not add something on this. I try to replace it with the newest technology, and then I'm seeing that it works. Yeah?
Okay, but I don't build technology. I have a factory. Okay, how do I get there?
So one of the things that I want to show the audience and people in general is that yes, this problem can be solved through education, but all the new technologies that you're talking about, both in terms of productivity and in security, are not as difficult as people would have us believe. There are pre-existing or currently existing technologies we can use today that can help you achieve most, if not all, of the different requirements you have. And if you want to build a completely smart factory that is completely unhackable and invite people to come and hack it and then prove that it's completely safe, and then you will say, okay, once we do that, we'll start production. Nobody's going to actually use a factory because it'll take you 5 years to get there. So what we want is to take the first steps. Use pre-existing standards, technologies that we have today. For example, PKI, or many others. You spoke about blockchain. To leverage them plug the holes that are apparent that you see today. Just because something can be hacked doesn't mean it will be hacked. There are smart hackers today that can hack into your home or hack into your car or hack into factories today, and we've seen that in the past. Doesn't mean it's always going to happen. But let's start building that education, that base foundation of security, and go from there.
Yeah, and I would like to add, there is this concept, and I have talked with a lot of people in industry, and in the industrial, like with big factories that make cars, they always say this: oh, I will never use the cloud to put my data there. They can be stolen by my competitors. This is crazy. Who is going to do that? It's the same concept of like Hillary Clinton having his server of emails in his house, in her house. It is a little bit of a concept where, because it's in your house doesn't mean it's safer. It means that it's closer to you, but these companies as Amazon or Fujitsu, we have gone through like security process that are going to be much more comprehensive for our cloud analytics that you are going to have in a server next to where you build your car. There people can go with a USB drive and steal it, they can unplug it, they can kick it, they can do whatever they want with it. You don't go through a security process. You think it's more secure because it's in your perimeter, but that's not true. And if you go to anybody, because there is the human factor, anybody can do anything with it, and they will do bad things with it. They will put a wireless plug in there so they can connect with it without moving to the office. So people on OT and in big factories and big industry need to start trusting people that have more knowledge of them on security controls in the factory and also in analytics. Again, this concept of like, I'm more secure because it's in my factory will kick you sooner than later, because that is basically not true. You have not gone through any evaluation which is as strict as Fujitsu will have in their premises, in their servers, or Amazon or Microsoft. So you need to understand a little bit that is a fallacy.
Okay, so that's really interesting. If I could dive into that a little bit deeper here. So the cloud is not necessarily less secure than something that I can control on-prem. It is fair to say that I don't have as much control because somebody's managing that for me. But what do I actually do in order to have this trust that you speak of in these things, right? If I go with a big name vendor, does that mean I automatically trust them? Are they automatically secure? Or how can I do this bottom-up approach that you mentioned, where I want to be able to trust them, but I want to be able to have them assert that level of trust, and I want to be able to validate against it. How do I do that? Because I'm in the factory space, I'm not in the security space.
I'd like to start with that one.
Okay.
But first of all, the factory is going to be brownfield. So you're not going to go in there and say, okay, you got to replace all these things, and you got to go get them from a certified vendor. So you have to deal with what's there. So obviously there's going to have to be some technology and techniques that you use. But I think what we say is it's about assurance. So you can specify the requirements to your vendors and your component vendors. You can ask them to deliver to meet those requirements. But you have to verify them. You have to assure that actually what they're saying and what they're delivering is what you're getting. Now, with regards to brownfield, I'd just like to mention the brownfield issue, because in most of these factories, yes, they will have a chance to introduce new technologies, and those new technologies could be a lot more adept from a security and safety point of view. But the existing brownfield, there's different techniques that need to be applied here. And one of the key techniques is to isolate them, to limit the exposure of those items, and create boundaries so that we can control who's talking to them and who they're talking to. And so in the short term, I see a different type of solutions and techniques being used to deliver interim security. But it's really important that they have the overall vision of where they go, and I think that the security framework gives that kind of, starting to get to the vision so they can start understanding where they need to go, and then start planning interim steps that they can take in the short term to increase their security posture.
Yeah, so it is, when you say, what is the first thing I should do in my factory? As JP pointed out, isolate. Isolate use smart routers to isolate and segment your factory. So critical PLCs are in one side and non-critical are in one side, and you understand what you have. Second, monitor. Use an OT monitoring capability which knows what traffic is in your network, understand what traffic is in your network, and try to prevent bad traffic to be there. Start to move slowly, fast, to a more connected factory, a more smart factory. So first add smart security to your dumb factory, and then start moving your dumb factory to a smart factory by using certification, and like understand the identity of your devices. And I started using analytics in the cloud, not on premises, because again that's a bad idea. Understand, have a good partnership with whatever company you're using for analytics, so you know if there is something goes wrong with your data, you understand what it is. But it's the same thing as using your mail server or your Gmail, like instead of like the company email. So it's a little bit that way, you just have to trust someone. But it is a process, obviously. You don't want to go jumping around, but the first part of this process is to turn your dumb security or your old security into smart security. And again, this industrial internet security framework we release provides this guidance on how to transform your factory in a more factory with a smart security and smart devices there.
I have to disagree with something Jesus said a minute ago.
Oh no.
He argued that the cloud is more secure, safer than equipment in the factory. I have to disagree with that. For example, in France, it is illegal to connect certain kinds of industrial networks to the cloud in such a way that messages are exchanged through the internet with the cloud. It's just too dangerous. The second law of SCADA security, all software can be hacked. The cloud is software. The third law, every piece of information can be an attack. The only way to compromise a plant is to send an attack into the plant, somehow, through a network perimeter on a USB key. You put these two together and we've got an opportunity for compromise. To me, yes, we want to do wholesale export of data into the cloud, by all means. Use the example that the Boeing speaker gave. We've got an aircraft. It's in the air. It's producing, what was it, 0.5 terabyte of data per flight. By all means, if we have the capacity, send some or all of that data in real time into the cloud. Get the analytics. But when that data comes back, we do not want messages from the cloud going straight into the jet engine saying, turn this parameter to this value and that parameter to this value. If the cloud has been compromised, no matter how much we trust it, we're in deep trouble for everybody who's sitting on that aircraft. When instruction comes back from the cloud, and it has to come back, in order to benefit from the cloud, we've got to be able to send information back into our processes. It's got to come in through a hardware-constrained interface. A signal like, given my analysis of weather patterns and the current state of the aircraft and, your deadlines and, we recommend from the cloud switching from operating mode 39, safe operating mode 39 to safe operating mode 47 for this engine for the rest of the flight. That's a much safer method of sending signals into the physical process than exchanging messages with the cloud. It's not that the cloud is wrong. It's that, message exchange is dangerous. And the other, another principle is we need to trust local sources of information more than distant ones. If the cloud says there's no aircraft anywhere around you, and our radar sensor says you're on a collision course, who should we believe? Which one are we going to believe? We're going to believe the local sensor. These are all principles for safe, reliable control that I think need to be captured.
Well, I think that you are like looking at, as what they said, you are looking at the down factory that has to be have a smart security, and I agree you should not make message flow widely to the cloud. That obviously is not what I said, and I will never say that. You have to first segment, do critical. But now what you're saying, I can always send a message that you're talking about self-destruct the factory from inside the factory. By saying that if you put the message in the cloud, somebody can destruct the factory, the risk is the same. The only difference is I have to walk to the factory. And if I am a bad guy, I'm going to walk to the factory. I'm going to go to the factory with my laptop and I'm going to do the physical attack. It's not going to be that much of a difference, except I have to pay $2,000 for like a plane ticket to the factory. We need to understand that while we send messages from critical, I totally agree with you that, and you guys are doing a great job of trying to create this segmentation of what is critical and how can it be dialed so not bad things come out. That's transforming a dumb factory with a smart security. But saying that cloud, we cannot control a factory remotely because that can cause an incident. Again, it is this thought of like, oh, if you have to put control so that doesn't happen. That if you send a message of like self-destruct the factories will think, wait a second, where is the message coming from? Why am I destructing the factory? And get remediation on that. But this message can come from inside. Even if it's not in the cloud, somebody can send a message with a button there. And this button can be controlled with a wireless because I can put a plug there and control it from outside.
So I want to follow up on that. When you have a factory, you have practically one goal, it is productivity. You want produces something quicker, faster, with more quality. This is your goal, and this is a top-down goal. And the first thing is you have to find out how brings cloud and other technology advantages in that. So you want to increase your productivity. And one thing, for example, is that a company says we have a new component, maybe it's a robot, and we upload data in the cloud, and we analyze your data to see if your robot gets soon a malfunction. That's definitely something which increases your productivity because your downtime is lower, you get a warning except a crash. And this is nothing principally dangerous, like this you said and the Boeing person said, because it's uploading of data. But when your cloud connectivity is then not really addressing this one way, it is just open, then you have a security issue and you have to address it. Another example is, as modern the systems are, as more software-based it is, and if more software-based something is, if more updates you get, because software is always full of bugs. And you see this on operating systems, easy in your cell phone. 10 years ago, you hardly updated anything in your cell phone, or 15 years ago, now you switch your cell phone and every day is some apps get updated, you don't even know why, you just trust it works. And in a factory floor, when you have hundreds of endpoints or something, you not think every time, should I update this or not? The system does it automatic. But you have to be sure that this update cannot bring a virus in. And this is one of our points where we say the code of this has to be integer. So the company who makes this endpoint has tell you and describe a way how we make an update, and you can validate that this is a secure way. Otherwise you have another security breach. And this is just some examples. You will go with things that brings advantages, and then you have to check this specific features on security issues.
Well, okay, so go ahead.
Just to quickly add to that, predictive maintenance, optimization, analytics are real-world IoT use cases that will bring ROI to companies. So companies will do that no matter what, and they need to do that to stay relevant in today's way. So we have to move beyond and say, let's not do this, versus, hey, yes, we need to do this. Now, how can we secure this? And so having said that, there are simple ways, resources that we can use today to do that. For instance, if for the IIC, but also for the general public, we have the security claims testbed that people can bring their solutions to and validate whether they've performed to or conformed to certain criteria. I would encourage all people here to go and question your vendors, whoever they are. Even if it's AWS, even if it's a large vendor, if it's a small private consultant cloud vendor, or even a device vendor, how do you secure your systems? Explain that to me. Learn that and make sure that they are implementing the right security and following open standards-based protocols and not having some obscure security way in which they are implementing it themselves. So question them, and this will lead to an effect where everyone starts thinking about this and starts implementing it from the get-go within the system. So build security from the start and question people who provide it for you whether they are doing the right things or not.
Okay, so that's interesting. So we're going to build in security from the start. Now I'm addressing the challenges in my factory environment. I'm a brownfield solution. We talked about that. I'm starting from brownfield. I need to do things now. There are solutions in place, and there are things that we can do, and there is a roadmap towards the future. But might not be completely clear on how that works. But one thing that as a manufacturing person was confusing to me up here was that you're both talking about control. Several of you have talked about control, and it's not quite consistent to me. So it sounds like you were talking about the control, the manufacturing control. So that's certainly one definition of the control, and we've heard the approaches to that, and the limitations of control, restrictions on control, and the boundaries around that. But we've also had a couple of hints towards control, as in what I control in my environment versus what I control in the cloud. I don't have as much control in the cloud. But if I want to do predictive maintenance, and I want all these features, I need to leverage the cloud, or some kind of component that I have less control over. Besides the fact that I don't have control over it, that's my data. And I have razor-thin margins. And my competitors would like to get my data. So in the concept of this predictive analytics, what is the guarantee that my competitors aren't using my data for their own gain?
I'm going to interrupt your speech for a second.
Yes.
Sorry. We're actually running out of time, but they're having such a great time. We're going to let them keep going until you disappear.
This is your opportunity.
Don't disappear now, stay. But I'm going to disappear, which, trust me, for somebody my size is even harder. Unfortunately, is there another session? I just want to remind you that there will be a lunch get-together for non-members that are interested in participating in moving forward in the smart manufacturing task group. Because remember, you're not doing smart manufacturing, you're doing stupid manufacturing. Me too. You can talk to Cheryl, who's sitting over here, Kathy, who's sitting over there, or one of our co-chairs sitting right here, John Cole, and we'll make sure that happens. And I'm sorry for the interruption. Keep going until they disappear.
Well, thank you. We just have a few more topics that I think, listening to this conversation, were not quite clear to me that I'm, as a manufacturing person, very interested in. That top one, where we ended up with cloud. What about my data? Where's the privacy controls? How do I control my data? What assurance do I have that it's actually even safe to go to a smart factory environment?
Yeah, I can say something about that. This is also a clarification. So when we talk about privacy, we means always human-related data. So we not talk about my production data. This is confidentiality. It is a part of security, and this is what we address in IISF as well. And of course, it contains a lot of information about your production. It contains how your product looks. You get possibly a lot of data from computer design direct in robots, and this information should never exposed. So when a system, and this is, you have the same situation you have with your Microsoft Windows at home. There is always rumors, passwords are scanned and uploaded, and this is of course a conspiracy. That's not true. Yeah? But other data possibly you don't want get uploaded. They are used, and it is important that you can have control over that. So now I use all of this word. So you ask your manufacturer which data you uploaded, and can I see this data? And when you change this, can you tell me you changed the structure of this data? So you have to need control over this, and this is something before you install and buy your machine.
But there's that word again, control. Who owns that data? That's my data, isn't it? Is it?
Well, obviously. Okay, so again, we have a test bed which actually do exactly that. It's the factory operations test beds. When we collect intelligence with the test beds, it's like a couple of factories in Fujitsu, and we evaluate this data in a cloud form. And we actually allow people to use their own algorithms to evaluate this data, to provide us with more information about that will have been missed, you know, we don't have maybe the algorithms and maybe somebody else has. So obviously it's our data, and there is a process of sanitation of that data, so it doesn't provide any relevant information about certain processes that you don't want to do. You just have to have the understanding of what are you going to do with the data and what kind of controls you want in that data, what kind of privacy with the data, and it is possible. We have been working on that. So obviously there is different restrictions, and if you have super critical data you just don't want to reveal, there is ways to do that with like encryption and more strict controls. So there's ways to control that.
Right, and so you mentioned the magic word there, privacy, right? Did you want to follow up on that?
Yeah, I just wanted to add that one of the key things we learned from our friends from Industry 4.0, or automating manufacturing in Germany, is that there's this legal component to the privacy. And so how do you enforce something that's in a contractual agreement that you might have with your partner? It's in your ecosystem. How do you enforce that in the actual system that's actually, collecting the information and distributing the information? So I think we're going to see a lot more focus in this area to make sure that the way the systems are built are protecting the privacy of the entities, and that they capture the relationships for sharing data amongst the entities.
So as the manufacturing representative up here, I'm glad to hear that, because that keeps me up at night, right? So I like to know that. But I'd actually like to hear from the real manufacturing representatives. We can maybe take a question or two from the audience. Does anybody have a security-related, a trust-related, a privacy-related question for our experts up here? This one was first, and then we'll do that.
How do you stop something like Stuxnet?
Yeah, everybody's jumping in that. You guys are there.
Stuxnet is relatively easy. When the POC from Siemens would have code authentication, it would not be possible. At least not, and when, of course, the Windows system accepted a virus. There was another weakness, so it was an OT and an IT conflict. So, but this is, I think Stuxnet really changed the industry, and there is a book, a complete book about Stuxnet, where we really showed step by step what happened, and it is really very to read. So after that, you know what you ask your implementers, what is important for your own factory.
So something like that will never happen again?
Oh, it will be happening again. On a higher level, or in so-named stupid factories.
But if Siemens plugs that hole, doesn't that mean that can never happen again?
Siemens, I don't know if one of Siemens is here. Siemens had a very good excuse. The PLC and the software was illegally used by the Iran government, so we're not responsible for that.
Well, okay, so, but that's not the security approach, right? So the security approach is they will find another way around it, right? So what is the solution to that type of problem?
I'd like to weigh in if I may. I spent way too much time on Stuxnet in 2010.
Designing it?
No, not designing it. Anyway. The truth is, I'm not that clever. And, a great deal of nonsense has been written about Stuxnet. I would know. I wrote a bunch of it. I took the artifact, the Stuxnet worm, and tested it against this antivirus system and that whitelisting system. And the whitelisting system defeated it and the antivirus didn't. So I concluded whitelisting was stronger, and whitelisting is the way forward to prevent the next Stuxnet. I tested against this intrusion detection system and that intrusion detection system, and this one caught it and that one didn't. So I concluded this one was stronger, and that's what we should go, we should be recommending going forward. That's all nonsense. In hindsight, our best intelligence, our best insight is that the artifact was designed to target one specific site with a detailed knowledge of not just the design of the site, but the design of security of the site. It did not defeat whitelisting, even though there are ways to defeat whitelisting. All software can be hacked. It did not defeat whitelisting because it did not have to. Presumably there was no whitelisting deployed there. When we have an adversary that sophisticated, that they can design an attack for the specific defenses we have, there is no way to stop. There is no cybersecurity technology we can deploy to stop that attack. What we have is an espionage problem. We need to escalate to our own national intelligence agencies, not try and do it ourselves. If we have two-way encrypted connections to dozens of cloud providers, nobody needs to produce the next Stuxnet. They're just going to come in through a compromised cloud provider. If we have glued shut all of our USB ports on the control networks the way a lot of people did, it will do no good as long as we still have firewalled connections out to the IT network. We need to get much smarter about security. That's probably, I've got a whole chapter on Stuxnet in my book.
I actually have to agree with Andrew in this one. It's like saying, oh, how can I stop a nuclear bomb to detonating, right? It is, well, you can stop the missile, but if somebody has 100 nuclear bombs end up detonating and destroying your city. But obviously, that doesn't mean that you cannot do anything about it. You can have anti-missile defenses, understand your enemy and have, but he considers this correct. Like, if you know all the defenses and how to, it's going to be complicated for the defenders to do that. That's why what we cannot do is to leave sites totally unprotected, because even that will make that playbook on how to take control. And you say Stuxnet, but I would say the main problem is that Stuxnet got so simplified for hackers that a kid with in their basement are going to create their own Stuxnet and drop it to us because it has nothing else to do. That is problematic, and that is happening faster. The same thing as crypto, ransomware, which is encrypting your files, was, I discussed that 8 years ago and people told me it was nonsense, and now everybody is dealing with that. It took 8 years, but it was not nonsense. I knew it was going to happen because I did a proof of concept of it. And I was like, hey, this is going to happen. It was like, this is very difficult. Who's going to do it? It must be a national state doing that. No, it's like a public-private key, used to encrypt files. The same thing with taking control of a factory. It seems like, oh, it's so complicated. No, if you have all the PLCs that are in the factory and you have a program where you have a playbook which says stop factory, and you just have to press a button. Obviously, you have not done that. Somebody else has done that for you. But at the end, you're the one orchestrating the attack. Again, it's about how much money the attackers have and how proficient they are. But they are getting cheaper to do these attacks, so we need to be smarter about our security.
Right, so the motivation is a big factor in that, and the access to the tools. So a script kiddie version of Stuxnet would certainly not be a good thing in anybody's mind. We have one more quick question, and then we'll wrap this up.
Yes. First of all, I think we are still underestimating the problem and size of cybersecurity in industrial. And it's not about security, it's about new type of risk. And one of the reasons, it's part of my question, that we still have a separation of knowledge and experience between IT world and OT world. And I would prefer, maybe for the next meeting, we will have a honest discussion about threat model and attack vectors for industrial environment. Since Jesus he mentioned ransomware, we have a lot of cases with industrial fraud when people steal physical assets due to knowledge of SCADA. We have a SCADA as a service for bad guys. They are moving very fast. And my question, because we still have a separation of duty and knowledge in the real plants, what is your advice? Who should be responsible person in a plant for OT cybersecurity?
Can I take that? I would say everyone.
No,
everyone in the plant.
No,
let me add to that, and then you can tell me if you disagree or not, which you're welcome to. First of all, everyone should be responsible for security. We have various analyst reports that say that the next big wave of attacks will be from rogue internal agents. So the people problem has to be solved. I'm not saying that's the only problem to solve, but the person problem everyone should be using the best security practices, because we've been talking about tools and techniques and other levers that we can push and buttons we can press. What we haven't addressed is that the people have to be educated to first use these things securely. For a year or so back, we had hacks against various US retailers like Target. I was involved in the investigation for the company that was providing security to that hack. And what we realized was we were able to protect against that kind of attack, but that company had not configured the software correctly to prevent that. So first thing we do is have education, solve the people problem by telling them, okay, this is what you have to do. These are the best practices. That's the first answer on who is responsible. Everyone is. The next step on who is responsible is that the owners or enter company that owns it. Doesn't matter if you're IT or OT, or if you are the CEO, or if you're the plant automation engineer. You are responsible because you work for that company, and you are ultimately responsible to the end consumers of your product.
Well, I have a private conversation with Andrew about this. Remember that? I asked you, who pays for OT security? And he told me, IT people. Obviously, they are not going to pay for it because they don't care. Right? So that's the problem we have to address. As you say, this is a problem difficult to address because OT security is dumb because IT security people don't put money on it because they put money on data security. And that is extremely problematic, and I have discussed how to resolve that, and it's, as he says, it's a part of how to change the company management of that. And probably Andrew or Marcellus will have to add on how to do that, because it's problematic.
Well, are we saying that my OT staff has to become security experts?
I think you need a top-down design for that. You said, first I need a person who is responsible, have the knowledge to understand the problem. And this is not much different from a factory plan leader today who knows all the mechanical things, who knows how a system has to be maintained. And so then it goes down, and I agree with him. I would not say the word responsible. I would say he should be aware. It means today, when you have a assembly line which works efficient, you educate your people, not just how you use the parts, you also explain to people how a bad behavior could look. For example, a weird noise could show that something get a malfunction soon, and you expect that this person go to the reader and say, look, there is something not working well, I tell you, or write a report every day. And reports get analyzed. And this education has to be expanded to security threats. That you say, I have the impression this machine do weird things while it should be in a sleep mode. What's going on here? Can you analyze this? And this should not be ignored. When you think about the target issue and all this stuff, there was warnings inside, but they get ignored because the people just was too busy or didn't care. And that is the dangerous thing. So it's a permanently awareness of this possible security threat. You have the same today with fire, with water, with power vests, and a lot of other issues. It just add one more.
Did you have a comment?
Let me add really quickly. It depends on the system. If we have an IT class security system for the plant, where everything's connected to everything worldwide throughout the internet, messages are flying all over the place, malware is flying all over the place, it's really hard. It's not clear who can be responsible and produce good results. If we simplify and we say, look, there's a fence around the plant, there better be a network perimeter as well. We'd better make the IIoT connections to the cloud respect the perimeter. We'd better make physical security respect the perimeter in terms of controlling the movement of removable devices and transient laptops and whatnot. Then it can be, it's simple enough that in a sense it doesn't matter who's responsible. Pick IT, pick OT security, pick someone. But what we have is a plant full of technicians. They don't understand security. What they need is to follow procedure. Give them simple procedures. Put technology in place. Put some smarts into the manufacturing process. Put a strong perimeter in place. And the whole thing becomes simpler. Everyone knows their role, and it all works.
Excellent. So on that note, there are solutions, we need to embrace them, we need to think about them carefully, and those of you facing the manufacturing challenges of the future, I hope you got some value out of this on the security, the trust, the privacy conversations. So if we could have a round of applause for our panelists.